Today on Primetime Local News, I am joined by Emil Holland. He is a senior research fellow with the Global Institute for Food Security. Emil, how are you doing today?
Pretty good.
Now, the Global Institute for Food Security has partnered with the University of Saskatchewan to implement live imaging research, a project that you've spent the last little bit working on. Could you tell me a little bit about this research?
So in this particular case, we're looking at something called long distance signaling. So it turns out that even though plants don't have nervous systems like you and I do, they signal stresses along the plant. And so we're going to use cucumber plants. Cucumbers are a very well-studied plant for this. And we'll use cucumber plants and we'll watch the flow of both some specific elements and some specific nutrients. We'll watch the flow of those nutrients in response to plant stresses. When you do the conventional studies, you can see where things are, but you can't watch them moving to get there. We will be able to see changes in where things are in real time as we study these plants. And so this is a thing that we'll do with these snapshot images of the plant.
Yeah, you're getting a more in-depth look at what's actually happening within the plant. What do you guys have to find from this research?
And we can also look underground too, so we can see what's happening in the roots, and that's a very important part of this. And so being able to better see how this particular plant responds to stresses and how it signals, so chemical signals travel between the leaves and the root back and forth, and they stimulate different plant responses. Being able to understand those and follow them in these plants will translate into better understanding important crop plants like soybeans and canola and wheat and others. And so we'll be able to better understand how those plants respond to specific signals as well.
And then, so you said we're taking a closer look at cucumber plants. What specifically do you think that you're going to find within the cucumber plants?
Well, we will be able to follow some specific elements, iron and zinc and some other elements that are of interest. We'll be able to see where they are normally stored in the plant. And then we will stress the plant with stresses which are, again, normal in growing plants. So we'll impose these stresses and we will see whether the plant responds to those stresses by moving these important nutrients and how and more details of that stress response. And by being able to understand those stress responses, we'll be able to know more about this plant and other similar plants.
And it sort of seems like this will also allow for more accessible research.
We'll be bringing this thing to plant-friendly environments, and thus we'll be able to see what's happening in a plant when it's being stressed by the things that we want it to be stressed by, not by being stressed by being moved away from home, so to speak, or in this dry, cold sometimes or colder environment and not well lit. And so and plants respond to these stresses very, very quickly. We can run away. So when we don't like an environment, we can move somewhere else. They have to respond chemically to that environment to try to change it if they want to stay alive, because they're fixed, right? And so plants respond to stresses sometimes faster than we do. And so, it's very important when you're trying to understand what's going on in a plant that you're controlling all the aspects of the environment. And so being able to bring this imaging technology into plant growth facilities is a huge dream of mine.
Absolutely. It sounds, the way you're describing it, it sounds like it's a huge step in being able to understand how plants really, like as you said, respond to stressors and pass nutrients throughout its system. It's very exciting.
Yes, it is. It's very exciting. We've been working on this laser technology for about a decade now. So it's quite new. And we've been imaging plants from the beginning because they're a very, they pose the same challenges as other living things do. But they're very easy to get a well-controlled sample that you can, an interesting and well-controlled sample, so that we can advance the technology more quickly with plants than with any other living thing.
That's very exciting. Well, Emma, thank you so much for being able to chat with me.
Thank you.